All right, so we're going to start out with our factoring with what's called GCF factoring. That's greatest common factor, where we're going to see if there are common numbers in every single term that we're going to pull to the front. So basically, GCF factoring is backwards distributing. Okay, so you know when you distribute, you multiply a number times everything. We're going to put it in that form with a number, something in the front, and then things in the parentheses. So the first type is the GCF factoring, or common factors as it's also called. And we'll just do some examples through this, but what we're trying to figure out is which number divides into every single term, and also which variables show up in every single term. So with our common factors, we'll start with our first one. Say I had 4x squared plus 2x. So I want to break this down into a way that if I distributed it, it would come back to this exact same answer. So let's think about it. I always look at my numbers in the front, my coefficients first. I have a 4 and a 2. What number divides into 4 and 2? 2, right? So I'm going to be able to divide a 2 out of everything. I'm going to bring that to the front because 2 goes into 4 and 2. And then I look at my variables. Is there an x in every single term? Okay, so if there is an x or a variable that's in every single term, the one that you can bring to the front or divide out of it is the one with the lowest power. So which is the lowest power, the x squared or the x to the first? X to the first. So you're always going to take your lowest power out to the front. I can't take x squared out to the front because there's not 2 in this one to pull from. Okay, so 2x is going to be what I bring out in the front, because there's a 2 that's in common and also an x that's in common with both of these terms. Okay, so now essentially what we're doing is dividing each of the terms we have by 2 and by x. Dividing by 2 and by x. Or another way to think of this, and how I really normally think of this for my problems, is 2x times what gives me 4x squared. If I distributed, I should get what I started with. So let's kind of think like that. So 2 times what gives me 4? 2, right? And x times what gives me x squared? X, right? So if I was going to distribute, would I get my first term? 2x times 2x makes 4x squared. Does everybody agree that that's true? Okay. All right, so now we're going to keep our plus sign. We're going to go to our next term. I want to see 2x times what is going to give me 2x? 1, right? 2x times 1 gives you 2x. So we always want to double check and see if I distributed, would I get my answer? We already did the first one, and that was 4x squared. Then if I do my second one, 2x times 1, that is 2x. So think of this as distributing backwards. They give you the answer. You want to write how it would be before you distributed your work. Okay? All right, I'm going to give you guys one to try right now, see how you do. Let's go with 7x squared plus 28x. Actually, let's change it to cubed. 7x cubed plus 28x. So 7x cubed plus 28x. So the first thing you look at is see what's in common with 7 and 28. What goes into 7 and what goes into 28, same thing. And then you pick the lowest power you have for your variable. That's what's going to the front. So let's make sure that everybody pulled the right thing out to the front. So anybody want to let me know what came to the front before we do the stuff in the parentheses? 7 and then x, right? We can only do first power because we only have a first power right there. Okay, so now y'all fill in the rest. What needs to be in here? So 7x times that gives you 7x cubed.
I know the last number should be 4.
It should be 4. There you go. We did get a plus 4. I'll go ahead and tell you that. So all we have to do is fill in this one right here now. Anybody think they got it? Some of y'all said no. No. Okay, so let's think about it. 7 times what is 7? That's just 1. We don't have to put a number there, right? I've got x.
Is it 1x squared?
Yes, it is going to be 1x squared. You don't actually need the 1, but we do need the x squared. So let's see why that's true. 7x times x squared. Remember when you're multiplying with powers, you add the exponents together. So that's 1 and 2, which makes 3. And then 7x times 4 is 28x. Do you guys see how that distributes and gets what we wanted it to be? Okay. All right, so the next type of factoring that we're going to do, so that was our GCF factoring. Now we're going to factor quadratic trinomials. Trinomials means we have 3 terms. And we have a couple different ways that we can do this. But before we start factoring these quadratic trinomials and see how they break down, we're going to first multiply 2 factors together just so you see how it all builds upon one another. Okay, so the first kind we're going to start off with is when a is equal to 1. If we remember our a, b, and c in our problems, so these are the first kind. So the first thing we're going to do, we're going to multiply 2 factors together. So I'm going to show you what a common answer would look like, and we're going to see how that answer came to be. And it's going to be a reminder of distributing 2 times, or some of you might have called it foiling before in your Algebra 1 class. So this is what your answers are going to look like, and we're going to see how we got to that from an original problem. So we'll see the arrangement of that. Before this, remember if you have 2 terms and 2 terms, do you guys remember how to distribute? You start with your first x and you multiply it times everything in the second set of parentheses. So we're going to do that first. So x times x is x squared. And x times 3 is 3x. Remember, you will be needing to turn these notes in as soon as this lesson is over in order to get credit for your homework assignment. So if you're not writing this down, you might want to get some paper out and start doing that instead of doing whatever else you're doing instead. Okay. All right. So now we're going to move on to the 2. We're going to do 2 times x and 2 times 3. So 2 times x is 2x. And what is 2 times 3? 6. Thumbs up if this rings a bell, if you remember doing this from your other math classes, your double distributing or your foiling. Okay. And then we combine like terms at the end. So if I'm looking, it's almost always the terms in the middle. I can combine the 3 and the 2 together, and 3 plus 2 makes 5, right? Good. So our final answer, if we were just going to multiply these together, would be x squared plus 5x plus 6. But what we're going to be doing today is they're going to give us this original, this will be our problem, and we have to come up with this as the answer. So we need to see how we can go from here to here. Okay? So what we've got to look for is we're going to look for these numbers at the end. We're going to look for the 2 and the 3 in this instance. Our numbers in the front, when A is 1, are always going to be X and X, and we just got to figure out the other two. So let's see how they get those numbers, okay? How do 2 and 3 relate to get to 6? What did you have to do with 2 and 3 to get to 6? You had to multiply them, right? So these two numbers here are going to multiply together to get our last term. So the two numbers that we've got, they're going to multiply to get 6. All right. And how do 2 and 3 relate to get 5? What do you have to do with 2 and 3 to get 5? You've got to add them together because we had to add them together right there. So our two numbers that we've got there have got to add together to get our middle term. So what we're going to have to do is we're looking for two numbers that multiply to get our last term and add to get our middle term. So we're going to start and think about factors of our last term and figure out which ones we can get to have a sum of this middle one. Okay? So if I were doing this problem and I didn't know this already, I would say things that multiply to get 6 are 1 and 6, right? And 2 and 3. And I figure out which ones I add together to make 5. Well, 2 and 3 add to get 5. 1 and 6 add together to make 7. So I would choose the 2 and the 3, right? So we're going to work a good number of these just for you guys to have some practice. I'll throw in some with negatives as well so you know how to do those. I'll write down the problems first and then we'll go through them. So we're going to work through these 4 problems. These are all quadratic trinomials where our a value is equal to 1. We're identifying two numbers that multiply to get to our last and also add to get to our middle. So our first one that we're going to do has just plus signs, and the other ones have got some minus signs that we'll have to deal with in a minute. All right, so go ahead and get those written down. And I know in some of your Algebra 1 classes, your teacher made you write down all of the factors of the last number, and then you had to like circle them, the ones that added to that. You are welcome to do that on your paper. I don't care. But I know that for some of these numbers, you can just go through it in your head and figure out what adds to that middle term. Okay, so let's start with our first one. We're thinking of things that multiply to get 24 and also add to get 10. So we could just go through some factors of 24. I'll just write them so you can see them if you need to visually see them. So we got 1 times 24. Does that add to get 10? No? Okay. We have 2 and 12. Does that add to get 10? Mm-mm. 3 and 8. No. 4 and 6. Does that make 10? Yep, so it looks like we found it. So we set our two sets of parentheses. You've got x and x. If it starts with x squared, you always start at x and x. And plus 6 and plus 4. Okay, you want to double check it. Positive 6 times positive 4 makes positive 24. Positive 6 plus positive 4 makes positive 10. Okay? All right, let's move down to the one with the 12. We have a -7 in here, so we're going to have to pay attention to that in a minute. Anybody think they know what multiplies to 12 and adds to 7? Anyone want to tell me? Think about your factors of 12. Is it 1 and 12? Oh, Shalia's got it. Shalia knows. She said it is 3 and 4. Good. So 3 and 4 are going to be our numbers. 3 times 4 is 12. 3 plus 4 is 7. And we got to worry about this negative in a second. We need it to add to be a negative and multiply to be a positive number, okay? So I want to look at the multiply to be a positive first. For something to be positive, you have to have a positive times a positive or a negative times a negative, right? A negative times a negative makes a positive. But in this case, we want it to add to be a -7. So we have to have negatives in our answer. So we can double check it. -3 times -4 makes a positive 12. And -3 plus -4 makes a -7. Everybody agree that our signs are okay in this problem? Okay. Donovan, focus. All right, our next problem, we've got 5. We want it to multiply to get 5, and we want to make it add to get 4, but we've got an issue here a little bit with this negative at the end. If something's going to multiply to be a negative number, one has to be positive and one has to be negative, right, to make it be a negative number. So what happens when you have a negative at the end like this is that the numbers might actually end up subtracting. It'll be kind of weird because if you think about it, the only thing that multiplies to 5, right, is 1 and 5. But when you add 1 and 5 together, you don't get 4, you get 6, right? But because that was a negative at the end, one of these numbers needs to be negative. So it's actually going to do some subtracting. So let's think. If I want -4, I should probably have a +1 and a -5. Does that make -4 when you add them together? Yeah, if I had switched the signs, it would have made a +4, and I didn't want that. So when you have a negative at the end, when you're trying to come up with your addition in the middle, just think it might be things that are getting subtracted from one another because that negative is involved. So let's look and double check. +1 times -5 makes -5. And +1 plus -5 makes a -4. And our last one with our signs. What are the only two things that multiply to 5? 1 and 5. To get 4, do I want 1 minus 5 or 5 minus 1? I want 5 minus 1, so it needs to be a +5 and a -1. Okay, so if your number in the middle is positive, if you've got a negative on the end, like these two, if the number in the middle is positive, your bigger number needs to be positive, right? If your number in the middle is negative, your bigger number needs to be negative. If that's something that would help you remember those. Any questions on this kind of factoring? Thumbs up if we remember this, if this is, we're kind of thinking about 8th or 9th grade again, maybe so, okay. All right, the next kind we're gonna do are difference of squares. These are my favorite because they're so easy. A difference of squares, those two words, difference means we have a subtraction problem, and squares means both of the terms are perfect squares. Okay. This is the formal formula for it. If you've got a number squared minus another number squared, this is how it factors. Whatever was squared in the first one, that's going to be the A, and whatever you had squared in the second one is going to be your B value. So if you have a difference of squares, it factors into A plus B, A minus B. Once I show you one or two, you'll say, oh, that's all? I can do that. No probs. I'm going to write out 4 of these again. We'll do 4 of these, and then you guys, we have a couple more types. I'm going to do the ones on the top, and I want you guys to do the ones on the bottom. Then I'll ask somebody to help me figure out what it is. Okay. So x squared minus 16, x squared minus 36, 4x squared minus 25, and 49x squared minus 100. If you'll notice, all of these numbers that I've written are perfect squares, so you should identify that at the beginning. Remember, our perfect squares are like 2 squared is 4, 3 squared is 9, 4 squared is 16, then 25, 36, 49, etc., etc. Okay. So if I notice that this A is where the x is, so my A value would be x. And what squared gives me 16? What squared is 16? Yeah, I see some of you mouthing it. It's 4. So I can rewrite this if I want into x squared minus 4 squared. And now it looks exactly like the format that I have written here. My A is x and my B is 4. Okay, so when I'm going to factor it, it's going to be x plus 4 and x minus 4. You guys go ahead and try the second one, the x squared minus 36, and then I'll ask somebody to tell me what you got. Think about what squared gives you 36, and that's going to help you with your answer. Let's see. Okay, let's go with Zasia. Help me out with your answer to this problem. Zasia, did you hear me? Can you tell me the answer to this one? Yes, you, Zasia, you. Uh-huh.
I said you're gonna pay for my insurance. I don't know.
All right, what squared is 36? All right, Zasia, we'll figure this out. What squared gives you 36?
You said 4 times 36.
No, what squared is 36? What times itself is 36?
6, 5.
All right. Yeah, 6. So x squared minus 6 squared, right? So our A is x and our B is 6. So now we're just going to write it like this. So you can tell me how it goes. It's very similar to the one we just did, but instead of 4s, we're going to replace them with 6s. So tell me what to write.
So x x plus 6.
Good.
And the other one will be x plus 6.
And x what?
X minus 6.
Yep. There you go. Good job. So the first one's a plus. The second one would be a minus with that. Okay. All right. I'm going to show you guys how to do it when there's a number in the front of one of them, and then y'all are going to work the last one by yourself. Malachi, you're not muted. Just a reminder. All right. So here we go. We've got 4x squared minus 25. So when there is a number in the front, especially if this number is a perfect square, we can split that up as well in a difference of squares, okay? So what times itself gives you 4? 2. What times itself gives you 25? 5. So here we go. And we know that x times itself is x squared. So when we split it up, it's going to be 2x plus 5 and 2x minus 5. So if you have a perfect square that's in front of your x squared, you also break it down into that square. Hey, you guys try the 49x squared minus 10. Remember that 7 squared is 49 and 10 squared is 100. And Taylin, I'm going to call on you, so go ahead and get ready. All right, Taylin, what is your answer?
You talking to me?
Yeah, you, Taylin.
7x plus 10.
And?
7x minus 10.
Good job. So 7x plus 10 and 7x minus 10. Because 7 squared is 49, 10 squared is 100. Everybody all right with our difference of squares? These are my favorite. I like these.
Hold on, let me write this down right quick.
Okay. I'm not going to, oh yeah, I'll just go right here. Okay. The last type that we're going to do today is when we have a greatest common factor and an a equals 1 combo with our trinomials. So we have to notice first that there's something that we can pull out of everything, and then we factor it from there. So it's a combination of the first two things that we did today. I'm going to have to reformat your homework a little bit, and I'm going to take some out because we won't have time because our class was shortened to get to our last kind of factoring that a is not equal to 1. We'll do that next time before y'all do your study guide though. So I'll teach it to you. It just won't be today. All right. So I'll change your homework up a little bit. If you've already started your homework, sorry, I'm going to take some problems off of it. All right. So here we go. Let's say that we had a problem like 2x squared plus trying to think of a good one. 12x plus 10. So we have 2x squared plus 12x plus 10. If you notice, the number in front of our x squared is not a 1. We have a 2 right there. So what needs to happen is we always, if there's a number in the front, you always want to make sure that you can't pull something to the front. There's not a common factor in everything. Because if you can do that, it's going to make it a lot easier for your problem. So if I'm looking at this problem, do you notice that there's a number that divides into every single term? What number goes into 2, 12, and 10? 2, right? 2 goes into 2, 12, and 10. So we're going to pull a 2 to the very front, okay, before we do our factoring. Is there a variable that's in every single term, an x that we can take to the front? No, just the number 2. So we're going to take the 2 to the front first. So this is our backwards distributing that we're going to try at the beginning. Okay? 2 times what is 2x squared? Is it x squared? 2 times x squared is 2x squared. Okay. 2 times what is 12x? 6x. And 2 times what gives us 10? 5. Okay. So we did our GCF, we pulled that number out, and now we have a problem here that we can factor like we did at the top. What multiplies to 5 and adds to 6. So when you do those, you just bring down the number that you had, you just carry that down in the front with you. So what are our two numbers that multiply to 5? 5 and 1. And does that also add to 6? And they both are going to be positive. There you go. So 5 times 1 is 5, and 5 plus 1 is 6. You're trying to multiply for the last and add for the middle. All right, let's try one more of these. So 3x squared minus 30x minus 33. Is there something that can come out of all three of these terms? Anything that can divide out of all three of them? Yes, the number 3. Good. And that's x squared minus 3 times what is 30? 10. Good. Minus 3 times what is 33? 11. Okay. So now we got to work with what we have on the inside. We're looking for what multiplies to 11. So what are the only two things that multiply to 11? 11 and 1. So those are our only options, are 11 and 1, and we just have to somehow make it equal to negative 10. We want negative 10. So which of these needs to be negative, the 11 or the 1? Let's see.
The 11.
Yeah, the 11. So let's see why.
Oh, my fault.
Negative 11 plus 1 makes a negative 10. If we had it swapped, positive 11 minus 1 makes a positive 10. Okay, so remember, if you have a negative in the middle, it's going to have to be the big number. It's going to have to be the negative one so that it will stay negative. Okay. All right, so we just skipped the GCF or the A is not equal to 1 problems. We'll do those next time at the very beginning. I'm going to go ahead and modify your assignment really quickly, so don't start the CUDA problems quite yet until I'm done doing that. So I'll let you know. It'll take maybe 3 minutes.